let's do these last few examples. They all involve the same area, but we're rotating that area around three different things: the line y equals 1, the x-axis, and the y-axis. So let's graph this out. We've got y equals 1, y equals 1 over x, and x goes from 1 to e. I'm just going to use Desmos to graph this. I know what it looks like, but Desmos can do it more neatly. So let's look at that. All right, we've got y equals 1. We got y equals 1 over x. And we're supposed to go just from 1 to e. So I'll tell you what I'm going to do. 1 less than or equal to x less than or equal to e. So it only gives us that little bit right there. And y equals 1 is supposed to be the upper bit. So really what we're looking at is this, it's shaped a lot like that example we did earlier. So I'm going to make a copy of this here. We're starting off with this area. We're taking that area there. And I'm going to go ahead and make a few copies of this for each part. This is only telling us to set it up. I'll just make one copy for now before I wreck it. All right, first part says rotate around the line y equals 1. All right, so y equals 1, that's going to give us this for our upper half. And so this is going to be a disk. The radius, or actually, it shouldn't do the radius first. You need to do the thickness first. Thickness on this is going to be dy. And the radius is going to be from here to here. So that's going to be 1 minus 1 over x. So the volume of this thing is going to be pi times the radius squared dx. I think I said dx up there, but the thickness is dx. And our x goes from 1 to e. All right. This next one, it says to rotate around the x-axis. Okay, if we rotate around the x-axis here, then the other side is going to look like this. It's going to be down here at -1. It's going to look like that. So when we draw in a disk, I'll do it in red. If I draw in a disk, it's going to look like this and this. And I'll try to give it a little bit of a 3D effect. So in this case, we're going to use washers. The thickness is going to be dx. And let's see, what else? We need the radius. The little radius, that's from the curve down to there. So this point is 1 over x comma x. Got that backwards. X coordinate is x, the y coordinate is 1 over x. This piece here, the x coordinate is x, the y coordinate is 0. And up here, the x coordinate is x, and the y coordinate is what? 1. All right, so little r, actually let's do big R first. Big R is 1, little r is 1 over x. And since this is a washer, the volume is going to be pi times the integral of big R squared minus little r squared times the thickness. And we're still going from here over to here, so we're going from 1 to e. Now the last one said to do it from rotating around the y-axis. Okay, so if we take this and rotate it around the y-axis, then we've got, let's see, here's the y-axis. We've got to come over here the same amount. Note this right here is the point 1, 1. This is going to be the point negative 1, 1. And this is the point E1. This is going to be back over here at the point negative E1. So we've got that. So in this case, our thickness is going to be dy. And let's see, what else? This is going to be a washer. These are going to be flat washers, laying down washers. So I'm going to pick a point here in the middle, y. And my drawing is not very symmetric, but that's supposed to be the center of the circle there. So that's y. That's my little radius, or my inside and my outside. So to come up with these radiuses, we've got to convert everything into, we've got to put everything in terms of y. So let's look at this. This point here, its y-coordinate is y, and its x-coordinate is e, because it's on that line. Now this point right here, its y-coordinate is also y, but to come up with what the x-coordinate is, we've got to solve this for x. If you just take the reciprocal of both sides, you get 1 over y. So let's see, our little radius is going to be, the little radius is the distance from y over to here. So that's 1 over y. And the big radius is the distance from here over to there. That's it's not y, it's e. Because the distance from here over to there is e. So our volume is going to be pi times the integral of, let's see, big radius squared minus little radius squared dy. And my endpoints, since these things are lying down, the endpoints go from the lowest to the highest. So on here, that's going to be from here up to here. So at the top, y is 1. What is it at the bottom? Well, to figure that out, we need to know the coordinates of this point. This point, its x-coordinate's e, and its y-coordinate is 1 over e. So our bottom endpoint is 1 over e. And this is our answer.